Here we have a question to find the area of the region enclosed by the given polar curves. So first thing I did, I plotted the function to see the graph of it. So I have some idea. It's 1 plus cosine theta in the calculator. And this is a cardioid, right? That shape. So I have this graph on my whiteboard. You can see we need to find all this area. So if you remember correctly that this was 0, this is theta pi, and theta is going from 0 all the way to pi, and then pi to 2 pi. This is one full revolution of the graph, okay? So if I just find from 0 to pi, that should be good enough, and then I can double it up. Now we know from our formula the area of a region bounded by a given curve, which is f theta is 1 plus cosine theta in our case, from theta alpha to theta beta, and we are going to do from 0 to pi, then the formula is this: alpha to beta integral half f of theta square d theta. So that means in our case, area is going to be 0 to pi. 0 to pi is going to give me the area of this top portion, half f of theta square. F of theta is 1 plus cosine theta square with respect to theta. Now see, we want to find the whole cardioid area. That means I need to double it. Whatever area that is, that was just the red portion. If I double it, I get the area of the whole cardioid. That 2 can cancel. So basically we just have 0 to pi integral of 1 plus cosine square theta. Let's open that square using a plus b whole square is equal to a square plus 2ab plus b square. That means this would be 1 plus 2 cosine theta plus cosine square theta d theta. Now here it's easy to integrate 1. It's easy to integrate 2 cosine theta. But for cosine square theta, we need to do some manipulation. So let's leave 1 as is and 2 cosine theta as is. But cosine square theta can be replaced by, if you guys remember the formula, 1 plus cosine 2 theta by 2. 1 plus cosine 2 theta by 2. That's from trigonometry with respect to theta. Now we can integrate the whole thing. Integral of 1 is theta plus integral of 2 cosine theta is 2 sine theta plus this is half is outside and integral of 1 is theta plus integral of cosine 2 theta is sine 2 theta by 2, and the limits are from 0 to pi. So all we need to do is put the top limit minus the lower limit. So let's put the top limit. Pi minus 2 sine pi plus theta by 2 is pi by 2. Half multiplies inside, sine 2 pi by 4 minus, when I put 0, this becomes 0, this becomes 0, this becomes 0, this becomes 0. Everything is just 0. So I don't really need to write that. So pi plus pi by 2 is 3 pi by 2. Sine pi is 0. Sine 2 pi by 4 is 0. So the answer to the area of cardioid is 3 pi by 2.